All right, everyone, welcome to the second lesson in Module 2. We're actually going to just continue with our multiplying and factoring of polynomials here, but we're going to do a little bit more in the factoring sense. And the multiplying is just going to be done to kind of help us then see how to factor. Okay, and we're going to be looking at a couple different strategies here. So let's get started here. So example 1 here, we are asked to use a table to assist in multiplying x plus 7 times x plus 3, right? This is something that we saw in the last lesson, if you recall. So, you know, typical table here, the x plus 7, they wrote that across the top here, and the x plus 3, they wrote that across, or, you know, down the kind of column there. And then you create your table by drawing some lines right here like this, and then you draw lines through the plus signs as well. And you arrive at these answers here by multiplying. You know, for the example, the x squared, you arrive at by multiplying the x's together there. And then you arrive at the 7x by multiplying that 7 and the x together there. And you arrive at the 3x by multiplying the x together with 3, so on and so forth. Now, the final step here, which they didn't really show, is you should add all these terms together. So it'll be x squared plus 7x plus 3x plus 21. And then you can combine these like terms, and so we end up with x squared. Well, I guess we can say this equals x squared plus 10x plus 21. So let's do the same thing here. We'll do one more practice with this, multiplying 2x plus 1 times x plus 4. Go ahead and pause the video and try it on your own. Okay, so hopefully you gave that a shot on your own here. And we'll just draw the table, and again, line through the plus sign, line through the plus sign there. So this will be 2x squared. This will be 1x, or just x. 2x times 4 is going to be 8x, and then 4 times 1 gives us 4. And so again, we'll add all these things here together, and so we'll get 2x squared plus, I'll go ahead and add the like terms, 9x, right? That's going to make a 9x right there, and then plus the 4. Quick little note here too, we talk about polynomial expressions. A polynomial expression is either a numerical expression or a variable symbol, or it's the result of placing two previously generated polynomial expressions into the blanks of the addition operator plus blank, or the multiplication operator blank times blank. Okay, so really a polynomial is essentially, it's a number, a variable, a product of numbers or variables, or it's the sum slash difference of these three things. So if you add up a bunch of numbers or variables or product of numbers and variables, that creates a polynomial too. Okay. In exercises 2 through 6, then, we're asked to multiply the following binomials. And note that it's all the binomials are given in one variable x with a degree of 1. And we're going to write the answers in standard form, which is this form right here, ax squared plus bx plus c. Standard form in general for a polynomial is it's just the highest power first, then the next highest power, the next highest power, so on and so forth. So let's multiply these out. Okay, I'm going to use the distributive property here. So again, we've done this already. So if you recall that, pause the video and go ahead and do it on your own. If you need some refresher, watch maybe me do one or two of these. Then you pause the video and try some on your own too. Okay, so here we go. So we'll do the x times the x times the minus 7, 1 times the x, 1 times the minus 7, and so we'll get x squared minus 7x plus 1x minus 7, and we just combine like terms to get x squared minus 6x minus 7. Okay, here for the x plus 9, x plus 2, this will be x times 2, so that's going to give us x squared plus 2x, and then the 9 times the x and the 9 times the 2 will give us 9x and 18, which results in, oops, don't need parentheses, x squared plus 11x plus 18. Okay, x minus 5, x minus 3. So again, we'll do x times the x times the minus 3, which results in x squared minus 3x. And then we'll do minus 5x minus 3, and so that's going to give us minus 5x, and then negative 5 times the negative 3 gives us a positive 15. Combining like terms there gives us x squared minus 8x plus 15. Okay, I know fractions are not everyone's favorite, but again, we can multiply this out here. It won't be too bad. X times x, x times minus 1, 15 halves times x, 15 halves times minus 1. And so we'll get x squared minus 1x plus 15 halves x minus 15 halves. Okay, we'll combine like terms here. And so negative 1 plus 15 halves. Remember, negative 1 is the same thing as negative 2 over 2. And so we get x squared plus 13 halves x minus 15 halves, like so. And then the last one, again, multiply. So x times times minus 3/4, minus 5/4 times x minus 5, or minus 5/4 times minus 3/4. So again, multiply, so we get x squared minus 3/4 x minus 5/4 x, and then 5/4 times 3/4 is positive 15/16. And then again, we combine like terms. Minus 8/4, which is really just 2. And then plus 15/16. Okay. So describe any patterns you noticed as you worked. So I want you guys to go ahead and think about that as you go back through these problems. Pause the video, maybe take a look back, and from 2 through 6, do you see any patterns there? And then once you've done, unpause the video, and I'll describe the pattern that we really want to focus in on here. Okay, so hopefully you took some time to look at those patterns here. Again, and you might have seen a lot of different things here. There's a lot of, it's not very vague directions, right? But what we really wanted to focus in on here is how the original problem here results in the final answer. And you'll notice there's some interesting relationships, right? So for example, all of these start with just an x, right? X, 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 so on and so forth. Okay. You'll also notice, though, that they have numbers, right? There's a 1 and a negative 7 there. Here's a positive 9, positive 2. Here's a negative 5, negative 3, so on and so forth. And without having to distribute all this stuff out, we can kind of go from here to here if you take a look. So for example, that x squared, right, that comes from multiplying the x and the x together. This negative 6, where does that come from? Well, it comes from adding these two numbers together, right? Same thing here. 9 and 2 makes 11. Negative 5 and negative 3 makes negative 8. 15 halves and negative 1 makes positive 13 halves, so on and so forth. Okay, and then what about this number these numbers here at the end? Where do they come from? Well, they come from multiplying these two numbers together. 1 and negative 7 makes negative 7. 9 and 2 makes 18. Negative 5 and negative 3 makes positive 15. Positive 15 and negative 1/2 makes negative 15 halves. Okay, so that's the gist here. Describe any patterns you noticed as you worked. We always had an x squared. The middle term, we'll call it. Middle term, like that's this term right here, was the sum of the numbers and the binomials. And the last term was the product of the number and the binomials, the product of the numbers. And the binomials. And we're going to use that in the next video to work backwards, using an answer like this to break it back down into the two factors. Okay, so we'll stop there for now, and we'll see you in the next video.